Hey, this is Chris Bale, Professor of Sociology and Public Policy at Duke and the Director of the Summer Institutes in Computational Social Science. In this video, I want to take you behind the scenes of a digital field experiment that my colleagues and I in the Duke Polarization Lab ran in 2017. And I hope this video will inspire you to run your own experiments and learn from our success, but maybe more importantly, some of our failures. It's my pleasure today to talk to you about my own personal journey through the world of experiments in computational social science. My name is Chris Bale. I'm a professor of sociology and public policy at Duke. And I just want to give you a sort of behind-the-scenes tour of some of the first large-scale field experiments I've run in my career using bots. And sort of combining some of the other sources of data, like digital trace data, that so many computational social scientists are interested in these days. So I'm going to begin with something that many people already know, which is that in the US, we're a pretty deeply polarized country. Between 1994 and 2014, we've seen, depending on how you measure it, now there's some nuance here, there's different ways of measuring polarization. But generally speaking, we are either becoming a more polarized country or we already were a pretty polarized country. And if we look at the ways that people react to questions about things like climate change, racial discrimination, the size of government, we see that around 2014 and more recently, we see that Democrats and Republicans tend to take pretty different perspectives on issues. I want to say briefly, this talk unfortunately is going to focus mostly on the United States. There's a lot of interesting heterogeneity in terms of how polarization is unfolding around the world. The US certainly isn't the exception to the rule. There's a lot of other countries experiencing similar transformations. But there are also others where political polarization is actually declining, which a lot of folks don't know, I think. So I want to time travel a little bit. Again, this is going to be a little bit of an autobiographical talk. My goal today is to sort of introduce you a little more to experiments in computational social science and sort of take you on a behind-the-scenes tour of an experiment. You're going to see how even the best laid plans sort of don't always work out as planned, but also see some of the opportunities that are created by computational social science and experiments in computational social science. So we're time traveling back to November 2016, and here is the infamous New York Times needle, popularized by the data scientist Nate Silver. And somewhere around early November, the forecast, the chance of winning the presidency, was predicted to be 82% for Clinton. I think that number even climbed a little higher in the final needle. I like to call this needle abuse. Of course, as we all know, there was quite a surprising outcome against most experts' predictions, most of my political science friends' predictions. Donald Trump was, of course, elected president. And there are many other examples of sort of stunning political developments around the world. Around the same time, Britain experienced the Brexit referendum, where of course the country voted to leave the European Union. And at the time, which feels like 5 million years ago here, 3 years into the COVID pandemic, many people were becoming concerned about social media echo chambers. So here we're looking at some Twitter data, and these are politicians or elected officials in the US. And so you have our Democrats over here and our Republicans over here, and the sort of lines between them indicate that they are following each other on Twitter. And no matter whether we look at politicians or here we can look at news organizations, we tend to see the same type of pervasive clustering according to political identity. So Republicans tend to follow Republicans, the Democrats tend to follow Democrats. And if you want to check out these data a little more, you can check out our tool on polarizationlab.com. So why do people care so much about social media echo chambers? Well, for a long time now, not only academics, but also a lot of sort of tech leaders and politicians have worried that, social media allows us to surround ourselves with like-minded people, and maybe even encourages us to do so through algorithms that may reinforce our human tendency to kind of seek birds of a feather, like birds of a feather sing together, as sociologists watching this will know. And that idea goes all the way back to the post-war research of the sociologist Paul Lazarsfeld. And since then, we've seen it happen in cable news, we've seen it happen in all sorts of other places. But I think it's fair to say that concern about echo chambers kind of reached a fever pitch somewhere around November 2016, after the election of Donald Trump, when we began to see a lot of real concern about sort of separate societies, right? That the Democrats and Republicans in particular were living in sort of separate ecosystems. And I'm going to take you on a little bit of a tour of my own career to explain how I wound up finding myself running a large field experiment on this topic. I started out in computational social science, mostly being interested in descriptive research. I was, really interested in natural language processing, and I had written a book that used some natural language processing techniques to try to sort of trace which types of nonprofit groups were shaping America's conversation about Islam after the September 11th attacks. And after that, I was very fortunate to get in, well, the get-in was good with Facebook data. And I did about 4 or 5 years of research on a variety of public health issues like autism spectrum disorders and organ donation. And one of the initial sort of ideas I had is, there's so much text data out there, and wouldn't it be great if we could get some other kind of data to attach to the text-based data, right? We all know that we can do wonderful things with text data. We can identify patterns. We can even maybe identify some kind of social psychological attributes of populations. We can start to study behavior, which is exciting for social scientists. But the problem with text-based data is we don't know who's creating it and sort of why, or who's not creating it, right? There's all these sort of really important questions that we often can't explore when we're only looking at, say, some data from Reddit or some data from Twitter. And back when I got into computational social science, it was still possible to collect data from Facebook pages, especially public Facebook fan pages. And so I had been interested in tracking some public health debates at the time. This was around 2012, 2014. And I began to sort of come up with the idea of building apps to do social science research. And the idea was sort of like, if you build an app, you can not only collect, I would argue, kind of richer text-based and behavioral data, but you can also sort of structure that data with the sort of tried and true tools of social science, like surveys. And so an example of this would be like, maybe I was thinking, when I first started thinking about echo chambers and whether this is really the thing that's dividing America, I thought maybe we could build an app like this, and this app sort of is taking in someone's Twitter data and comparing it to some other data sets which sort of look at the left-right distribution of people, and then a user could come in and get some kind of score about their echo chamber. So here you can see like I'm slightly to the left, and maybe you could show them some other stuff like, oh, you're like this, your Twitter network is most like this elected official or something like that. And then you could also, importantly, ask them some questions, right? Things like, how often do you use Twitter? What's your age, gender, all the things we can't get. We can take guesses with text-based data, but we can also ask all the questions that we might not be able to observe. And I think there's a lot of leverage there. I still think app-based research is a great option, especially now where we face new challenges related to privacy. And the sort of neat thing about app-based research is that you can kind of create a workflow where you can authenticate with a user and obtain their consent to collect their data, unlike a lot of work that's happened in sort of descriptive work with text data, especially on social media data. You can administer, again, supplemental surveys to sort of better structure the data. And then sort of importantly, and this is something I really am passionate about, we can deliver something that's of value to the people we study. Too often I think as researchers we're sort of greedy, we're just kind of taking from people and never giving anything back. And so with apps, I discovered in some of my early work, we could build apps that, for example, help nonprofit organizations reach a broader audience, and that nicely sort of incentivizes them to participate in our research too. Okay, so if you want to learn more about app-based research, I have a whole other series of videos on 6.io that describe how to build apps using tools like the R software Shiny, how to host them, how to deploy them, and all that kind of stuff. I'm mostly mentioning this because I want to explain how this research interest of mine developed into experiments. And really in the case of this question about echo chambers and to what extent they shape our political views, it's a really challenging problem, right? We might think that our social media networks are going to shape our political views, right? As you saw, I'm like to the center left here, so maybe I'm getting too much New York Times and I need to read more Wall Street Journal, right? And that we might argue then that means I would arrive at a different set of political beliefs. But it's almost certainly true that my political views are also determining who I follow on social media, right? So if I follow New York Times and not Wall Street Journal or not Fox News or whatever else. And so we have a really familiar problem in social science, which is endogeneity. We don't know whether this relationship here is being shaped by this relationship here. And though maybe with an app like the one I just sort of demoed, we could collect some better data and figure out, well, is this data accurate? Is it valid? We still couldn't fully randomize people. We couldn't ask the important question, what would actually happen if we could take people outside of their echo chambers in some way? Something that would not happen naturally, right? That's what we would really want to do to study this problem of whether social media echo chambers are shaping people's political views. In other words, we'd want to take sort of people, sort of break their echo chambers. Now, I also wanted to say a little bit about the story of this research. So I, as I mentioned, I was reading the press, I was reading studies, I have a background in social network analysis, so I was really interested in echo chambers long before the election of November 2016. But I had just started teaching a course in computational social science, which is a very weird thing back in November 2016. There weren't that many of them. And many of us who taught back then sort of struggled to say, well, what is the field? What are we doing? What counts as computational social science? And one of the things that I discovered in that class is sort of defining the field together was sort of the most exciting thing. So in every class, I had a sort of group research project where I would come with a sort of half-baked idea and say, hey, this semester to learn techniques like collecting digital trace data, text analysis, let's do a project together. And so my students and I started to talk about what that project might look like. We can easily scrape some Twitter data, right? As you know, if you've spent any time working with Twitter data, I can write 2 or 3 lines of code, and I can get the names of people who the names of the people who people follow, right? As long as their account isn't set to protected. And so a lot of people in that class, people like Taylor Brown, John Bumpus, Hao-Han Chen, Marcus Mann, Frito Merhoot, we all got together and we thought, okay, well, let's build an app, because that's kind of what I was excited about at the time. And we built an app, much like the one I just showed you, that would allow a user to put in their Twitter handle and then see sort of what their echo chamber looked like. And then we were going to ask them questions, and we had our IRB written up. We were ready to sort of go into the field. And coincidentally, semester ended, and then I immediately started getting ready for the summer institutes in computational social science. And the summer institutes are always just super exciting, right? I'm always exposed to a ton of new ideas. And this was actually the very first summer institute way back in 2017. And I had the good fortune to meet Lisa Argyle, and many other people who are sort of more seasoned experimental investigators than I was, and who really convinced me that I should give experiments a close look. Like we can learn so much with the descriptive data, and there's so much data out there, but unless we randomize, right, we really can't sort of take people all the way outside their echo chamber. And I lastly want to introduce Mary Beth Fallon-Hunziker, who is then, was also in my class, but was then an assistant professor of sociology at NYU. So as I mentioned, like, what we really would want to do is sort of take people outside their echo chamber in an experimental fashion, really leverage the power of randomization, allow the Democrat and the Republican to sort of step outside their side of the conversation and begin to maybe empathize with each other, or at least maybe better understand each other. And how do you do that? Well, at the time, again, this is roughly 100 years ago in November 2016, it feels like 100 years ago, before COVID, there was a lot of concern about misinformation campaigns, the Russia-linked Internet Research Agency. There was a lot of negative press around bots. There still is today, of course. A lot of concern that bots were spreading misinformation, antagonizing people, and so on and so forth. And yet, we began to start to think, well, could bots also be used to do some kind of cool experimental research? In other words, are there good bots that can be used for research? And we thought about a lot of issues here. I mean, this is in the early days of bot-based research, and we think a lot about ethics here at SIX, and so of course, one of our immediate concerns is like, can we control these things in a careful way? What will people think of interacting with bots? There were so many challenges, even just about designing the study in principle. Like, how does one use bots responsibly? And I'll talk a little bit about that as I describe the experiment that we ultimately did. But just trying to get familiar with this kind of new research technique, we came up with the following research model. It didn't just happen overnight. We wrote a proposal. The Russell Sage Foundation funded us with one of their presidential grants, which is a sort of a rapid response mechanism where there's an immediate problem in the world, and you can ask for, I believe it's between $5,000 and $50,000 to run an experiment. And here's what we came up with. So in October 2017, we surveyed about 1,600 Republicans and Democrats who claimed to use Twitter at least 3 times a week, who were over aged 18, and who identified as either Republicans or Democrats. So you can see right off the bat, this is not a representative sample of the US public. It is only people who use Twitter. That's only about 20% of the public. And it's only people aged 18 and over. These are US citizens. And they're also identified with a party. So there's lots of people who aren't identified with the party. And what we initially wanted to do, actually, was to test a hypothesis that sort of came out of some earlier work I was doing, which is that maybe there's a curvilinear relationship between how much who you meet on the other side, so to speak. So if you're a Republican meeting a Democrat, or a Democrat meeting a Republican, and whether your attitudes would change. So my kind of half-baked hypothesis was, if I'm a moderate Democrat, and you expose me to a moderate Republican, well, then I should probably become a little more moderate, right? But if I'm an extreme Democrat, meaning like I have really strong views in line with the Democratic Party, and you expose me to an extreme Republican, right? That's not going to go well, right? That's gonna devolve into some kind of typical social media fight where everybody just kind of gets more angry. So that was the initial plan. At the time, though, we had to find a survey firm that was willing to ask people a bunch of questions so we could carefully measure our outcomes. In this case, we were looking at a range of different outcomes related to their beliefs about politics and their attitudes towards the other party and things like that. And we asked for something like 2,500 of them, and they said, you can have 1,600, right? So right away we faced a decision, and this is the kind of stuff that when you read a final paper, you don't see all this stuff, right? And this is sort of like, experiments are messy, and you see the good stuff, but you don't see it sort of as it's unfolding. And we faced right off the bat a really difficult decision. We had wanted to have wanted to have like 4 different treatment conditions where moderate Democrats would follow moderate Republicans, and the extremists would follow the extremists, and so on and so forth. Or I shouldn't say extremists, they're people with strong views. And we had to make a tricky decision, which was, should we have 4 underpowered treatment conditions where we don't have enough people to make meaningful comparisons in terms of statistics unless we see these giant treatment effects, and we had no idea what size treatment effects we might expect. I mean, we had some intuition from previous experiments, but there wasn't anything quite done like this. So we're like, well, that's not great. Or do we do one treatment condition per party, just expose them to everyone, not moderates to moderates, extremists to extremists, and there at least we'll have a large enough sample where we can make meaningful comparisons between the treatment group and the control group. And that's what we ultimately did. And so basically people can complete this survey, and then 1 week later, about 60% of them got a seemingly unrelated survey or survey invitation from the survey firm. It was seemingly unrelated, and then it didn't seem to come from the same group of researchers. And they were simply offered up to $30 for following a bot that they were told would retweet 24 messages a day. Now, you can imagine what would happen if we said, step outside your echo chamber, right? Come on and try out this experiment, right? We've gotten all sorts of weird people participating in the experiment, right? Only people who are maybe curious about stepping outside their echo chamber. And that's probably a weird group of people in the landscape of the US today, right? Or if people sort of know that they're an experiment, they might behave differently, right? People who think that the point of the experiment is to change their mind might either get really upset and sort of voice responses that are the opposite of that, or they might want to sort of enact what they think we want to see, something that's often called the Hawthorne effect or experimenter effects in social science experiments literature. So so we got these people in. They agreed to most of them agreed, about 45% of the 60% agreed to earn up to $30 to follow these bots. So for the first few days, to sort of further make this randomization seem natural, the bots only tweeted pictures of serene, beautiful, peaceful landscapes, nothing related to politics at all. And then gradually, we sort of turn up the dial using some techniques I'll show you in just a minute that sort of increase the number of posts that people began to see from opinion leaders from the opposing political party. So these are people like elected officials, journalists, pundits, but also advocacy organizations and news organizations. And once we do that, we're able to sort of start not only looking for the type of treatment effects that we're interested in, what happens when you sort of, we're not really breaking their echo chamber because Twitter's only one thing that they're doing. We're sort of asking them to sort of step outside. Maybe they're perturbing their echo chamber is probably a better way of putting it. And the sort of neat thing is, in addition to having this large-scale experiment with a longitudinal survey design, so we resurveyed the people 1 month later, in November 2017, we're also collecting everything they tweet, everything they favorite, everything they like, the text of their bios. And if you're interested in social networks like me, we have daily slices of their ego network. We have the ego alter network, which is a very large network before and after the experiment was done. Just like for us anyways, and for me at least, it was a mountain of data. We're still analyzing this data 5 years after the fact. So a lot of data, and during the sort of 1 month survey period, we administered some additional surveys I'll describe in just a minute to deal with another problem that we ran into in designing the study. So what are these Twitter bots? Like, sort of how do they work? What do they do? Well, we got the idea to create sort of political bots from a measure that was created by a political scientist named Pablo Barbera. And Pablo, who's also a friend of the program, and you can watch his lectures on 6.io at 6 Oxford. And Pablo had a really interesting idea. He thought, well, if we want to create an ideology score for people on Twitter, we can say, take Lisa Murkowski, the senator from Alaska's Twitter account, and we can see who she follows. We can scrape the names of everybody who she follows. And then once we have a big graph of all the elected officials, a big network of all the elected officials, we can begin to use one of many different clustering techniques or pattern recognition techniques. The one that he winds up using is called correspondence analysis, but there's many others, to essentially detect patterns in who follows who, right? And with the intuition that people in one party are more likely to follow people from the same party. And so if people are mostly or exclusively following people from their party, then we might surmise that they are from that party and not another party. And the other sort of neat thing about this approach is that it also lets you capture sort of non-elected officials, right? We can score the elected officials through the way they vote, or the way they identify, or what party they're registered with. But something like CNN, right? Which those of you from the United States will remember this is like a moderate to moderate left TV station, right? That's a big part of the echo chamber. We don't want to leave out CNN or Fox News or even advocacy groups like Planned Parenthood or the Heritage Foundation, which is a right-leaning nonprofit. And so the sort of neat thing we did is collect the Twitter networks of all the elected officials and all the presidential candidates in the United States at the time, and that created this massive network of about 600,000 people. And unfortunately, that network not only includes a lot of interesting accounts, interesting for our purposes like CNN and Fox News, but also Bernie Sanders' niece and stuff like that, right? Which we don't want Bernie Sanders' niece in the sample. So we decided to sort of drop everyone except for the those who were followed by at least 10 elected officials. So that allowed us to create a much more manageable network of about 4,000 people. And our bots drew a name from the distribution that we created, again, by looking at patterns in who they followed on Twitter each hour. And if that account had tweeted, then our bot simply retweeted that message. So we didn't do anything really fancy. We didn't use like large language models or anything like that. We simply were just retweeting folks. We did, by the way, have to monitor. I, for a very painful month, got a Twitter notification every single time our bots tweeted, just in case the bot would do something like share fake news, which we, again, at the time we weren't sure this type of thing could happen, especially given the population and how charged things were at the time. So I have another lecture on 6.io where you can learn about how to create a bot, but I want to just briefly say that we did it by hosting a bot on an Amazon EC2 server. You can watch my tutorial, there's many others out there, about how to spin up a EC2 server. Essentially, it allows you to open RStudio in a web browser and let it run for as long as you want, or you could open 20 different versions of RStudio. And there's some code in past 6 lectures that you can check out to do that. In a nutshell, packages like the rtweet package will allow you to post a tweet like natively from the RStudio console. And I was actually writing this code this morning, and I forgot that it would actually post to Twitter. So you can see here, this is what I was. Funny Twitter notification. I'm a bot. Who said that? Yeah. Anyways, so be careful if you do this, but it is possible to post a bot. Now, I'm going to kind of take you through a whirlwind. I want to keep this somewhat short, so I don't have time to go into all the challenges. But let me just say that there are a ton of challenges. Again, when you read a field experiment, at the end it can seem as if everything was thought about and everything. But in reality, right, you can try to plan as best you can, but there's always going to be some challenges. And the first challenge, of course, is compliance. Like, how do you we're trying to get people to do something that nominally probably most people don't like, right? Most people don't like talking about politics in the United States, and they especially don't like hearing about the other party. So how on earth do you keep track of whether people are going to pay attention with the cutest animals on the internet? So with the help of my daughter, I identified these 3 truly identifiable creatures and presented them to our research group, who had come up with the idea jointly that we should have the bot retweet one of these creatures every day, and then we could ask them at the end of the week which picture did the bot retweet, and we could show them a bunch of other pictures, and if they could identify the animal, then we would consider them more compliant with the treatment. We also made the sort of critical decision to ask them whether they could also answer contents about the bot's tweets themselves. And this was actually another big debate. We had a lot of debates in the research team, as my co-authors would tell you, and this is why this was a debate, right? There's always this question of kind of external validity, right? Like, we can't, we incentivize people to want to pay attention to our bot, right? So we can't then say that, if the CEO of Twitter, whoever that might be, decided to, suddenly take people outside their echo chambers, we can't say what we saw happened because they presumably are not going to pay people to step outside their echo chamber. On the other hand, had we not given people this incentive, we couldn't know if they were just, muting us or logging off of Twitter. I mean, we could see if they unfollowed us, but we couldn't really know whether they were paying attention to the treatment we were trying to give them. This is a huge problem in experiments in social science, because if you can't know whether the people you're trying to give the treatment to are getting the treatment, then you might be comparing a treatment condition to a control condition where the treatment condition isn't treated, and then you might massively understate the treatment effects that you're expecting to observe. So that's a big problem in experiments in general, and field experiments in general. But again, computational social science gives us some sort of creative, we think, some sort of creative and interesting ways of trying to keep track of this. So we could write some code that just sort of checked our follower network of our bots and see that most people are following bots who we asked to follow the bots. We can look at who could answer the questions about the bots' tweets that we asked them. And then we could also look at who could identify the cute animals I just showed you. And so this is another way to sort of create better and more, we think, more accurate treatment effects by being able to account for compliance. Okay, so that's challenge number one. Challenge number two, again, something, one theme you'll see in this story of this research is that these were kind of mountains beyond mountains. Like, if you're in a lab and you can very carefully assign people to a treatment control condition, you can sort of like, you can do a lot. You can know what's going on, right? But now imagine you're running a field experiment on Twitter. You've got, more than 1,000 people involved. You can't possibly pay attention to them all day. You can't know what they're doing when they're not off Twitter. You can ask them some questions, but you can't really observe it. And so there's this other big question, we are not just randomly drawing people from a population and keeping them like the treatment group in one room and the control group in the other room, right? In real life settings, people are in a network, right? And so here, what you're seeing is actually our study population and whether they follow each other on Twitter. And what we discovered is, one of the big assumptions of experiments is that people are independent of each other, right? Because we don't want to treat one person and then have that person, like let's say this person here is in our treatment condition, but this person here is not, and then this person starts retweeting what we showed them, and then this person sort of by extension gets treated, and then we go to subtract the difference between the treatment and the control condition, and there's no effect, even though there was a giant effect because it not only affected this person, but also this other person who was following her. I say her because this is my favorite couple. This is the husband and wife, Democrat and Republican. And the questions get even more complicated as we start to look at these, these network components where you have sort of opinion leaders who may have larger followings, and then people can, of course, be connected to each other through other people, right? So these are the types of mountains beyond mountains that I think most social scientists aren't even aware. I certainly wasn't aware of until we got in and we're like, oh my God, people could follow each other on Twitter. What would happen, right? And so then we had to make the decision, okay, we got all this data. We were able to pull all their networks. That's when we discovered this problem. And then thankfully, we could intervene. We could say, anybody in these giant components, it's just too messy. We're going to drop them from the survey because we can't know how information is going to travel across these networks. And anybody in dyads like this, we're going to flip a coin and keep one of them in the study, and the other one won't be invited to participate in the study. We have a lot of other opportunities to analyze all sorts of questions around causal inference and networks using this data that I won't talk about. The other thing is poor survey data. Anyone who's run a survey is sort of probably familiar with this problem. Like, there's so many examples now. For example, Prolific, which is one of the survey vendors that some of you may be familiar with. It's a sort of on the cheaper side of survey firms. They recently experienced, I think, a 300% increase in the number of women showing up in studies. And it's like, what's going on there, right? Like all of a sudden overnight, turns out a TikTok influencer put out a video saying, hey, you want to make money? Like, you should go take surveys, right? And her following is largely female, and all of a sudden, this huge, huge problem for survey research, right? Now, we were working with a very reputable survey firm and did not expect to have those types of problems. But we realized as we began to do the study that we could actually look at the people we were studying on Twitter because we had their Twitter handles. Now there's some ethical issues here. There's, we obtained informed consent, of course, to do this, but we could actually go into people's accounts one by one. There were 1,200, give or take, that wound up in our final study, and we could actually try to see if they were who they thought they were. And what inspired us to do this is one of the things you can collect through Twitter's application programming interface is a location field, which is where people say they're from. And so I was sort of interested, I was looking at our data, I was like, wait a minute, Venezuela, where did that come from, right? And then I went to the Twitter account, and I was like, this person is speaking Spanish. They say they're in Venezuela, but in our data, they are a Trump voter from Oklahoma who has very negative attitudes about climate change, right? Like, what's going on? Much detective work later, we discovered that these people were probably unemployed computer programmers who were using Tor to mask their IP address in order to appear as people who they emphatically were not. And there were, upwards of 72 of them. Again, from one of the best survey firms. So something we wouldn't even know we had this problem, right? And these are people who are probably sort of throwing darts at a wall and responding to our survey, right? Presumably they speak English. We don't even know that they're understanding our questions, right? And we're taking their data as seriously as everybody else, right? So again, another sort of hidden opportunity to improve the science. Okay, so those are the kind of general problems. I'm going to kind of just show you the results and the rest of the design. We're only studying people in the US. They have to use Twitter 3 times a week. They have to describe themselves as either a Republican or a Democrat. We got a pretty good response rate. And what we use to study the outcome here, among other things, is something called the Ideological Consistency Scale, which is actually exactly what the Pew Research Center has used in about 18 surveys to try to produce estimates like this. It's a series of questions that allows you to place someone on a liberal to conservative scale. Because I'm trying to cover just the autobiography and biography of this study, I won't go into the technical stuff too much. You can check out the paper if you like, but it's questions like, do you agree or disagree stricter environmental laws and regulations cost too many jobs and hurt the economy, or the best way to ensure peace is through military strength? And of course, by linking the sort of Twitter data with the survey, we can control for all sorts of other stuff. Now it's an experiment, so in theory, all of this should be washed out due to the randomization, right? We should have equal numbers of people who have strong interest in current events and those that don't have a strong interest in current events, and then as long as we're randomizing within those two, have enough people in the treatment and control condition, this should sort of wash out. But we can control for all this sort of stuff. And if there's a variable that you really care about, like something like frequency of Twitter use or strength of partisanship, right? I told you earlier we had this hypothesis that the strong partisans might behave differently than the more moderate partisans. What you can do with experiments, which is great, is you can do something called block randomization, where you can say, instead of just flipping the coin for everyone in the study, you can put them in groups and then flip the coin within those groups, ensuring that you have even more statistical power to look at what's known as heterogeneous treatment effects, or subgroup populations, because we often, I think, wrongly assume that everyone's going to respond in the same way to a treatment stimulus when, in a lot of cases, and especially this one where we even had some theoretical intuition about why people might respond differently, we were able to flip the coin within different bins. And again, I won't go into the details. You can check out the paper if you want to learn more. We can then look at the representativeness of our study, pretty good in terms of geography. When we compare it to things like the American Community Survey, we had more women. So it's not a representative sample of the population, as I mentioned, because these are partisans who use Twitter. We had more people identified as white, some other issues like that. The biggest difference was actually age. We were able to use post-estimation techniques to correct for that age bias. If you want to learn how to do that, Matt Selganik has some excellent videos that are up on 6.io. You can learn about post-estimation weighting to look at that. But not a terrible sample, even though we were expecting it to be pretty biased. Another big problem in field experiments is, what if people leave the study, right? And what if people leave the study because of the treatment? Huge problem, right? Imagine we ask these people to go follow a bot that they don't know is going to expose them to messages they might not like. They start to follow the bot, they see that it's something they don't like, and they leave the study. Pretty sensible thing to do, right? But a huge problem for us. Because if the only people who stay in the study are the same people who are sort of unusually tolerant or predisposed to appreciate a diversity of views, then we're going to get a really weird idea of what the actual treatment effect is. Fortunately for us, we didn't see much attrition. We maintained about 89 to 91% of the sample, and we didn't notice differences across the treatment conditions or across parties. Even that alone would have made it really difficult to do the analysis for this study. Okay, so just to wrap up, I want to show you what happened. This is the effect of following a bot that retweets 24 messages a day from opinion leaders from the party that you do not identify with. and you're going to see the results for different levels of compliance. So how well could you identify those adorable creatures I showed you earlier? How many questions could you answer about the content of the bot's tweet? And you're going to see them separately for Democrats and Republicans. And this is a difference in difference estimate using something called compliance average causal effects, which take into account in the estimates using a two-stage least square model, basically what the treatment effect is at different levels of compliance. And here you can see, we didn't see what I think many people, including myself, would have liked to have seen, which is the Democrats who are following a Republican bot. We sort of wanted to become a little more conservative or a little less liberal. And what you see here is not much going on, but the size of this effect increases with compliance. So these are people who were able to answer all the questions. They became a little more liberal, not a little more conservative. Now this effect is not statistically significant, but because it increases with compliance, I suspect that had we had a much bigger sample, we would have seen a small statistically significant effect. But in the Republican side here, you can see that even those who only agreed to follow the bot, regardless of whether they ultimately followed it closely, showed significant treatment effects. They became, a little bit more conservative, and those who really paid attention became significantly more conservative, almost a standard deviation on our scale, which is a pretty large effect in social science terms. And so I would love to tell you a lot more about all of the text analysis that we did and all the machine learning models we tried to run to make sense of this data. And I can only say that it was very humbling, and we couldn't find the answer with the data we had, which is why I spent much of the next 3 years launching the Polarization Lab at Duke, which is an interdisciplinary effort that involves computer scientists, data scientists, political scientists like Sunshine Hilligus, and statisticians like Alex Wolfowski to try to do a major follow-up study in which we repeated the experiment using qualitative methods. I don't have time to talk to you about that today, but if you want to learn more about that, I just wrote a book that reports the results of that research. And let me wrap up just by trying to inspire some of you who are maybe a little gun-shy about experiments, about why I think it's worth a shot. I started out by saying my background was in more natural language processing, descriptive studies. I had done a little bit of engineering with apps, and that was helping me get at some of the stuff I couldn't see, but I really couldn't get at causality. And we all sort of gesture towards causality, especially when we do descriptive research, and we say, that this is something we can't quite get at, but we're still kind of making causal statements, right? And I personally, there are social scientists out there that won't believe anything unless it's a randomized controlled trial. I'm not one of those social scientists. My intellectual genealogy is I am the nephew of Pierre Bourdieu, who was famously critical of social science surveys. So I fully, respect that perspective, but I will say that there's an enormous space in between, being a sort of, uber positivist and a uber interpretivist. And now with advances in computational social science, especially where we can link text data to the treatments and other behavioral data and sensor data and survey data, there's just so many new questions about things that were once thought to be impossible to experiment on, things like culture, identity, gender. If you check out some of our other videos on 6.io about experiments, you'll see just a full range of really fascinating experiments. And so I just want to kind of try to inspire those of you who haven't yet explored this space. Give it a shot. The other really exciting thing about experiments is that though you can spend tons of money doing experiments, the experiment I talked about today, by the way, cost about $60,000. It took us about 5 months to write the grant to get that money. But there are experiments published in amazing journals like Science that cost almost nothing. And there are other creative ways to use bots without incorporating a longitudinal panel design, research by Kevin Munger and others, or other research looking at responses to hate speech, and also other experiments done outside the US that really are, close, the cost is close to zero or zero. So that's another really exciting opportunity. And if you are sort of gun-shy about building a bot, or you've never tried one, well, you can see now you can do it in one line of code. You have to also write code to collect other outcomes, so there are some startup costs. But then if you also think for a moment that if you can open yourself to the possibility of exploring platforms like Empirica, which did the hard work for you of building all the tough engineering, and in some cases even have graphical user interfaces where you can create experiments, the costs of experimentation have never been lower, and the time it takes to learn about it have never been lower. And I suspect that for years to come, we're going to be seeing experiments continuing to become more and more common in computational social science, and especially in areas where entrepreneurial young scholars identify ways to run experiments on topics that aren't usually experimented upon. So thanks a lot. I'd love to hear what you think about this research, and I'll look forward to seeing you again soon. Hey, thanks for listening to this video on running online digital field experiments. And I hope that hearing about the story of our work will inspire you to create your own field experiments. And hopefully you've been inspired to think about some of the real positives of running digital field experiments in computational social science. But also my hope is that I've made you more aware of some of the challenges as well. Thanks for joining me.